We continue with the exercises on domain and range of a function. For the next few exercises, we're just going to be concerned with domain. And you can see there's a whole list of exercises here. We're on page 2 now of the handout. And we're going to just work from the formula for a function. And in these kind of problems, again, we're only interested in domain. We are not going to try to find the range from a formula. That's quite a bit more difficult kind of thing to do. And we don't have to graph these, okay? But if you want to graph, or if a graph helps you, that's certainly okay. So as you go through these, I almost suggest if either graph by hand, or if it's, some of these are pretty strange. So you can use Desmos to see a graph. And it is kind of nice to compare your answer to the graph that you see in Desmos and think about how they're related to each other. So let's go ahead and get started on these, and I have recopied them onto separate paper so we have a little bit of room to work. So exercise 4 is find the domain of this function f of x equals x to the 5th minus 2x to the 4th plus x cubed plus 2x squared minus 5x minus 8. It's quite a mouthful. That's a function with lots of terms, many terms. It's called a polynomial function. We're going to study polynomials quite a bit later in the course, but for now, the only observation, we just have to make an observation here. So we have to observe that any real number value of x can be plugged in to give us a meaningful y value. Because it may take a while to figure all this out, but I can see no matter what I plug in for x, the same number, of course, in each term, I can work all that out, and I'm going to get some corresponding y value. When that's the case, you just have to make an observation here. There's no calculation to carry out. So we know that the domain consists of all real numbers. And there are many functions whose domains are all real numbers, and we love those. They're kind of like functions with no problems. Now, I want you to be able to write this answer in interval notation. So in interval notation, we're going to write parentheses minus infinity, comma, infinity, parentheses. It's not wrong to write the domain in words, but we want to get used to using interval notation here. So the preferred answer is in the box. I would accept words. If you're really stuck with interval notation and you write a domain explanation out in words, I would never mark that wrong if you state it correctly. But I want you to try to always write your answers with interval notation. Okay, exercise 5 in this section. Find the domain of the function f of x equals 1 over x plus 3. Now this is different from the previous example because here I can see that I cannot plug in every real number value for x to get something that makes sense. Because x occurs in a denominator, notice that f of 0, if I try to plug in 0 for x, I'd be writing 1 over 0 plus 3. Well, division by 0 is undefined, and so this output value is undefined. There's no y value here. Now, sometimes people get a little mixed up by this one because they'll say, can't I just throw away the 1 over 0 and keep the 3? And it doesn't work that way. You don't get to keep what you want and throw away what you can't. The 1 over 0 poisons the whole thing. The whole thing is gone. So if you divide by 0, if you're trying to divide by 0 anywhere in an expression, the whole entire expression gets thrown out. So f of 0 is undefined. X equals 0 is not in the domain of f. So what does our domain consist of here? In fact, that's the only problem number here. Any other value of x could be plugged in. So in words, the domain is all real numbers except x equals 0. But we want to turn this into interval notation now. So let's just think about a number line. If we wanted to include all real numbers except 0, we got to leave a hole at 0. We want everything less than 0. We want everything greater than 0. And how do we express this in interval notation? Now, if you watch the interval notation video, I said as soon as there's a hole, in interval notation, you have to use two separate pieces. So the only way to express this in interval notation is to express this piece as parentheses minus infinity comma 0 parentheses, because 0 is not included, union this piece, which is parentheses 0 comma infinity. So it's sort of like a big mess in interval notation, I would say. It's kind of a funny way to express the idea that we're just leaving out one number, but that's the way it goes. That's how we express all real numbers except 0 in interval notation. Let's do, I think we're going to do one more in this segment. Let's look at exercise 6. Find the domain of this function, the square root of 5 minus 2x. Now, here's the challenge with these domain problems. There is not one thing you look for in every single one of these problems. And so you have to realize there's different techniques that get applied for different situations. One kind of situation is where you have a variable in the denominator, like in exercise 5. In exercise 6, we have a totally different kind of situation. We have a square root involved. So we can only take square roots of quantities that are greater than or equal to 0. Because if I try to take a square root of a negative, if I try to take a square root of a negative number, there's no such real number, right? That the function value is undefined. So the kind of trouble here is we got to make sure our domain does not include any values of x for which we'd be trying to take a square root of a negative. Now that doesn't necessarily match up with where x is positive and negative. It's not so much x, it's the expression inside the square root sign. So the expression inside the square root sign is 5 minus 2x must be greater than or equal to 0. And I wrote those words. You don't really have to put the words in there. I just get this inequality. Okay? So it's very different from the previous problem. Now, we want to find out what this tells us about x. So I have to solve this inequality. I could subtract 5 from both sides, in which case I get minus 2x is greater than or equal to minus 5. And then I have to divide both sides by negative 2, right? And now here's something you have to remember from basic algebra. When you divide both sides by a negative number, the inequality direction changes. The direction changes. And that only happens when you multiply or divide by a negative number. I get x is less than or equal to 5 halves or 2.5 is the same thing. Okay. And so my domain consists of values of x that satisfy this inequality. So here we found out a condition to be in the domain. In exercise 5, we found out a condition that meant we had to remove a number from the domain. Here it's what it means to be in the domain. X less than or equal to 5 halves is going to be parentheses negative infinity comma 5 halves square bracket, because the 5 halves is included. That would give us a square root of 0 when we plug it in, which is perfectly okay. And just before we quit this one, I'm going to try to just squeeze this in. You could have taken that inequality and you could have just taken the 2x to the other side. You could have divided both sides by 2. The inequality direction does not change when you divide by 2. And you would have gotten 5 halves is greater than or equal to x. These two inequalities are the same. They're saying exactly the same thing. I know one has a less than or equal to, one has a greater than or equal to, but you can turn this one around, and if you put x on the left, saying x is less than or equal to 5 halves is exactly the same idea as saying 5 halves is greater than or equal to x, right? So the interval comes out the same in either case. There's only one interval. That's the domain of this function. It's kind of funny, it includes all these negative numbers, right? But that's because when you plug in the negative, because of the -2, you'll end up taking a square root of a positive later on when you get to the square root calculation.